Problem 16. Triangle A has two sides with length 25 and the bottom with length 30, and the triangle B has also two sides with length 25 and the bottom 40. Let's assume the height of triangle A is HA and the height of triangle B is HB. Based on the problem, we can calculate HA as square root of 25 square subtract 30 divided by 2 square. And that equals 625 subtract 225. And that equals 20. Now, we can also calculate HB in the same way. It equals 25 square subtract 40 divide 2 square, and that equals 625 subtract 400, and it equals 15. Therefore, we can see that HB equals half of the bottom length of triangle A, and HA equals half of the bottom length of triangle B, because a triangle's area equals half of its bottom length multiply its height. Therefore, the area of A and B should be equal. The answer is C. Problem 17. To solve this problem, let's first write out the prime factors of 588. 588 divided by 2 equals 294, and 294 divided by 2 equals 147, and 147 divided by 3 equals 49, and 49 equals 7 multiply 7. Therefore, 588 equals 2 square multiply 3 multiply 7 square. Now we know that W equals 2, X equals 1, Y equals 0, Z equals 2. So 2W plus 3X plus 5Y plus 7Z equals 4 plus 3 plus 14. It equals 21. The answer is A. Problem 18. In the first row, we can choose any number from the sixth side, and that's 1/6 of the chance. Then we multiply the probability from the second row. And if the first row we get number 6, then any number we get from the second row satisfies the requirement of the problem. So that's 100% probability. It equals 1. And then if the first row we got number 5, then the second row we can get from number 1 to 5 that are equal or smaller than number 5. So that's 5 out of the 6 choices in the second row. And similarly, if the first row we got number 4, then in the second row we can have 4 out of 6 choices that satisfy the problem. And we continue to do that to add 3 out of 6, 2 out of 6, and last number is 1 out of 6. So We simplify this. It's 1/6 multiply 6 in the denominator, and the upper side is 6 plus 5 plus 4 plus 3 plus 2 plus 1, and that equals 1 plus 6 multiply the 6 numbers divide 2. And we cancel the 6 out, we get it's 7/12. The answer is D. Problem 19. To solve this problem, we count the rectangles that are composed of different number of sections. First, let's count the rectangles that are composed of one section only, and that would be the inner one, this one, and the second one is this one. The third one is this one. So that's 3 one sections. One section. And for rectangles composed of 2 sections, we will have the first one, the second one, the third one, then the fourth one, and the fifth one. So we have 5 rectangles with 2 sections. Then for rectangles with 3 sections, there are none. And for rectangles composed of 4 sections, we will have 1, 2, and 3. And that's the maximum rectangles we can get. So 3 with 4 sections. So we sum them up, 3 plus 5 plus 3 equals 11 in total. The answer is D. To calculate the area of the trapezoid, let's draw a line from A that's perpendicular to the bottom. And then similarly, we draw another line from B that's perpendicular to the bottom. And assume it crosses DC at F. So now we know that AE equals BF equals 12. And because ADE and BFC are both right triangles, so DE equals square root of AD square subtract AE square. That equals 15 square subtract 12 square. And it equals 9. Similarly, we can get FC equals square root of BC square subtract BF square. That equals square root of 20 square subtract 12 square. And that equals 16. So now we know that DC equals DE plus EF plus FC. It equals 9 plus EF equals AB equals 50 plus 16, and it equals 75. Therefore, the area of ABCD equals 1/2 AB plus its bottom DC multiply its height AE equals 1/2 50 plus 75 multiply 12, and that equals 750. The answer is D.